Slider. The velocity of the object sliding down from the slider increases gradually at a constant rate till it reaches the base of the slider. The velocity of the object depends upon the steepness and coefficient of friction of the slope of a slider and the mass and configuration of the object too. The potential energy of the object gained at a height is converted into kinetic energy while sliding down. A car accelerating at a constant speed. The speed of the car upon starting the engine is less, as it gears up. The speed of the angular acceleration of the tires increases, thus accelerating the car. If the speed of the car is accelerated at a constant rate, then we will have uniformly accelerated motion. Gravitron. A gravitron works on the principle of the centrifugal force that keeps the body attached to the wall of the gravitron and prevents people from falling underground. Upon starting the gravitron, the centripetal acceleration of the gravitron increases at a fixed rate to a certain point where the centrifugal force is more compared to the centripetal force, and the body of the person remains attached to the wall due to the force imposed. Grinder. The speed of the rotors of the grinder increases gradually upon supplying power to the grinder machine. These rotors apply frictional force over the base of the grinder, thus causing the container of the mixture to rotate. The speed of the grinder increases uniformly till it acquires the actual speed. Ball sliding down from a steeper slope. If you keep the ball on the steeper slope, you will notice that the initial speed of the ball is less as it has more potential energy stored within the ball. This potential energy is converted into kinetic energy while it slides downward, thus increasing its speed constantly. Swing. A swing oscillates, decreasing its angle of oscillation frequently. In one oscillation of a swing, if you notice, the speed of the swing is the minimum when it reaches the 2 points, and while accelerating at a normal point, the speed of a swing increases uniformly. Skiing. The acceleration of the skier will increases uniformly down the slope while skiing on the steeper slope. To keep the momentum and regulate the speed and direction, the skier holds the rod in his hand to apply the pressure on the ground. Spinning top. The angular acceleration of the spinning top is the minimum when the axis of rotation is along its symmetric axis and the point of gravity lies around the tip of the top. The speed of acceleration of the top increases uniformly as the angle of gyration increases simultaneously. Spreading carpet. The folded carpet is in a form of concentric circles, and hence the length of each fold decreases within the folded carpet as the circumference of the concentric circles decreases. Hence, while spreading the carpet, the acceleration decreases uniformly after every fold. Ceiling fan. The capacitor of the fan stores some of the electric potential energy with it, and hence this energy is released when you turn on or turn off the power supply of the fan. You will notice that the speed of the fan gradually increases or decreases uniformly on turning the power supply on or off, respectively. Riding a cycle on a steeper slope. While riding the bicycle on a steeper slope, the acceleration of the bicycle increases at a constant rate. Hence, brake has to be applied while driving on a steeper slope to control the speed of the vehicle. Waterfall. The volume of water taking a jump from the top point of a cliff to the ground, the speed of the water increases down the cliff. This is due to the fact that the potential energy of the water is highest at the top of the cliff before taking a jump. Frequently asked questions. Is the clock an example of the uniformly accelerated motion? The hands of a clock move in a clockwise direction, covering a fixed distance in every interval of time. The speed of the hands of a clock remains constant, and hence the acceleration is zero. Therefore, it is not an example of a uniformly accelerated motion. Please visit our website lambdageeks.com for more articles on technology, engineering, mathematics, and various other domains. Scientific calculator and many more other tools.